Hello students, I am Dr. Rohit Prakash from Faculty of Chemical Sciences, Sri Ram Sarup Memorial University. Now I will start today about the hydroboration and oxidation reaction of alkene. This is one of the most important reaction of alkene for the preparation of alcohols. We have learned about the hydration reaction of alkenes, where we convert alkene to alcohols, and according to Markovnikov rule, the formation of product takes place according to Markovnikov rule. But here, the alkene, when we treat it with borane in THF, followed by the oxidation with hydroxide, sodium hydroxide, hydrogen peroxide in water, it gives alcohol. Finally, the alkene is converted to alcohol. In case of unsymmetrical alkene, the reaction takes place according to anti-Markovnikov rule. Means anti-Markovnikov rule, just we need to understand that the basic mechanism of electrophilic addition reaction does not violate. The course of mechanism is similar, what we have learned in other electrophilic reactions. The course of mechanism is similar, but the outcome, the product is according to anti-Markovnikov rule. Means if we analyze the whole reaction, the unsymmetrical alkene gets converted to alcohol according to anti-Markovnikov rule, and it is different from the electrophilic addition reaction when we perform it with the help of sulfuric acid. Now, what happens? The reagent is borane. The borane is actually borane exists in a dimeric form, diborane. The diborane is actually explosive in nature. It's highly volatile is toxic in nature. So we do not use diborane as such. We prepared the solution of diborane in THF. Now, the boron is electron deficient atom. So the borane acts as an electrophile, and THF has oxygen atom. No? The lone pair electrons of oxygen atoms behave like a nucleophile, and they fulfill the octet of boron. Now, the species which is formed actually is, if we see what is THF is tetrahydrofuran. So tetrahydrofuran donates lone pair electron to boron. Boron, thereby accepting the lone pair electrons from oxygen, develops a negative charge, and oxygen gets a positive charge. So actually, this is the species tetrahydrofuran. The furan is an aromatic compound. THF is tetrahydrofuran, means all the carbons, all the doubly bonded carbons get saturated. This is THF. Now THF is a nucleophilic in nature, which gives electrons to borane, and borane thereby accepting the electrons, उसका octet complete हो जाएगा. The octet उसका जब complete हो जाएगा, now this is the source. This species is the actual source of actual reacting species in case of this hydroboration reaction. Because borane, we do not use borane. We just use, as I said, the borane, borane exists in dimeric form, diborane, which is explosive in nature and is highly volatile in nature. And also it is toxic. So we make its solution in THF, and this is the species which is actually hydroborating reagent. Now, if we see the mechanism, how the mechanism proceeds. Now the alkene now adds, first step, the alkene has a pi electronic density above the plane, below the plane. Now this alkene adds to the boron. Boron is electron deficient center. It adds the boron. Now, as alkene starts bonding with boron, the boron gets negative charge, partial negative charge. Now, the carbon to which boron is getting attached is now not deficient in electron, but the other carbon gets electron deficient in electrons. तो इलेक्ट्रॉनिक डेंसिटी इस कार्बन पे कम हो गई. दैट इज वाई द स्टेट इज द टीएस, जो ट्रांजिशन स्टेट जिसके थ्रू रिएक्शन हो रही है, इट लुक्स लाइक कि कार्बोकैटायनिक लाइक ट्रांजिशन स्टेट है. नाउ दिस पॉजिटिवली चार्ज कार्बन पे जो डेवलप हो रहा है इस कार्बन पे पॉजिटिव चार्ज, नाउ द बोरॉन, नाउ दिस बोरॉन हाइड्रोजन बॉन्ड से हाइड्राइड ट्रांसफर होता है इस कार्बन के ऊपर. इस कार्बन पे हाइड्रोजन जो है ये हाइड्राइड इस कार्बन से बॉन्ड बनाना स्टार्ट करता है एंड साइक्लिक 4 मेंबर ट्रांजिशन स्टेट इस तरह से बन जाती है. सो व्हाट आई सेड कि बेसिक मैकेनिज्म ऑफ इलेक्ट्रोफिलिक एडिशन वायलेट नहीं हो रही है. दो द ओवरऑल एडिशन द प्रोडक्ट इज अकॉर्डिंग टू एंटी मार्कोनिकॉफ, बट द बेसिक मैकेनिज्म वायलेट नहीं हो रही. क्यों नहीं हो रही है? बिकॉज बोरॉन is electrophile and electrophile adds to that carbon. For example here the electrophile adds to that carbon which has greater number of hydrogen. तो बेसिक मैकेनिज्म फॉलो नहीं हो रही है. और साथ ही साथ जो हाइड्राइड है, हाइड्राइड गोज टू दैट कार्बन, फॉर एग्जांपल हियर हाइड्राइड गोज टू दैट कार्बन दैट हैज लेसर नंबर ऑफ हाइड्रोजन. सो बेसिक मैकेनिज्म वायलेट नहीं हो रही है, वो फॉलो हो रही है. चूंकि हमारा जो बोरेन है it gets converted after oxidation to alcohol. That is why it is the outcome, the product is different. Now through this cyclic four-member transition state, then it soon changes to alkyl boranes. The reaction does not stop here, as still there are 2 hydrogens present on the borane. This alkyl borane has 2 hydrogens, so it can add to another alkene molecule to form dialkyl borane, which can add to another alkene molecule to form trialkyl borane. So the reaction does not stop here. We get trialkyl boranes, and trialkyl boranes after oxidation with H2O2 in alkaline medium, they get converted to alkoxyborane. Further alkoxyborane changes to finally alcohol. So the overall reaction is broadly divided into 2 categories. First step is hydroboration, this one, and the other step is oxidation. Hydroboration, the result of hydroboration is the formation of alkyl borane. After oxidation, the alkyl boranes changes to alkoxyborane, and finally after alkoxyborane they finally change to alcohols. So the ultimate product of the reaction is alcohol. Now if we compare it with the what I said, it is if you examine the product क्या कह रहा है कि जो हमारा वाटर, द ओवरऑल एडिशन क्या है? ओवरऑल एडिशन OH का और H का है, मींस ओवरऑल एडिशन वाटर का है. तो वाटर का एडिशन हो रहा है अकॉर्डिंग टू एंटी मार्कोनिकॉफ रूल. मींस अगर हम अल्टीमेट प्रोडक्ट देखें तो OH गेट्स अटैच्ड टू दैट कार्बन दैट हैज ग्रेटर नंबर ऑफ हाइड्रोजन. इज इट क्लियर? So there are various examples, there are various derivatives of borane which are widely used. This reaction was initially developed by S.C. Brown and Mayo, and this is a very popular reaction for the conversion of alkene to alcohol. Thank you.